Hello and welcome to another WJEC A level physics question. This time it's question 3 from January 2010's PH2 paper, and it's a question about stationary waves on a string. So we've got a demonstration being shown in a diagram of a stationary wave on a string. We've got a vibrating pin on the left hand side, a pulley on the right hand side, some weights attached to the string to add a bit of tension there. And we can see, if you like, an image of the wave at a particular instant there, and we can see nodes and antinodes and so forth, but we'll talk about those later. State whether the following pairs of points on the string are vibrating in phase, in antiphase, or neither in phase nor in antiphase. So look at it at A and B. Now this is very simple if you just remember that for a standing wave, in between nodes being points of no displacement like here and here, every point is oscillating in phase, so the particles A and B are in phase. We also need to remember that the phase changes at every node, so the particles in between the next two nodes, for example C, are actually in antiphase with all of the particles that are oscillating between the first two nodes on the diagram there. So here we have in antiphase. Next we're going to describe how we could check this experimentally. So what we would do is use a stroboscope. The device basically sort of flashes light at a regular frequency. And we're going to set it close to the frequency of vibration of the string. Now what will happen then is that we'll see the string will appear to move up and down in slow motion. That would allow us to hopefully see that particle A was moving upwards while particle C was moving downwards, for example. Now progressive waves transfer energy through the medium and stationary waves do not do this, and we've got to give another difference between progressive and stationary waves. There's a couple of things we could go for. We could talk about amplitudes, and basically apart from attenuation, the weakening of the wave as it travels through a medium, the amplitude of a progressive wave, of every point on a progressive wave, is exactly the same. However, for a standing wave, the amplitude is a maximum at antinodes and a minimum or zero at nodes. Okay, next we're going to explain how in the above setup the stationary wave can be thought of as arriving from progressive waves. This is a very common type of question, and the basic idea is that we need two identical waves travelling through each other in opposite directions, and that's brought about by the waves reflecting at both ends here. So what we get is simply that we have interference between the incident and the reflected waves. For the diagram, we've got to deduce a value for the wavelength. So if we go back to this diagram, we've actually got 1, 2, 3, 4, 5, 6 loops in 1.2 meters. Each loop is half a wavelength, so we have 3 wavelengths in 1.2 meters, and hence the wavelength is 0.4 meters. Finally, the pin is vibrating at a frequency of 50 Hz. We've got to calculate the wave speed. We can simply use C equals F lambda, frequency of 50 times wavelength of 0.4, which will give us 20 meters per second, and I believe this was actually a unit mark question in the original exam. Thank you very much for listening. Please remember to like and subscribe, and feel free to leave any comments. Goodbye.